I'm Anil Kumar, and in this video, we will understand the very basic concepts of applying L'Hospital's rule. Normally, we say that if you need to find the limit as x approaches a for quotient of functions, let us say fx over g of x, and in case we have indeterminate form. Now when I say indeterminate form, we are saying either it could be 0 over 0 or let's say infinity over infinity, right? So let me write down here. Indeterminate form means what? When I say indeterminate form, we are saying that the limit when x approaches a, at that time f of x approaches 0, and for limit x approaches a, g of x also approaches 0, right? You should understand that g of x will never be equal to 0, right? Now, it could be both approaching 0, or the second case could be where they are approaching infinity, right? It could be plus or minus infinity, right? So in either case, we have indeterminate form. In such cases, the limit of this function is actually equal to the limit when x approaches a for derivatives of these functions, f dash x over g dash x. So that is L'Hospital's rule. Now how does it really work? To understand, what we can do is we can take a closer look at two functions. Let us say, we'll just sketch them here. Let us say we have a function which is f of x. Let's say this is the function which is f of x, and let me call this function f of x, and we'll consider this point here where it is approaching, this is a for us, and the function f of x is approaching 0 as x approaches a. You get an idea, right? So this is x-axis, that is the y-axis, right? So the function f of x approaches 0 as x approaches a. Now if I consider another function, let us say g of x, which is, let me sketch another function here. Let's say kind of like this. So let this function be g of x. Now g of x is also approaching 0 as x approaches a. And if we need to find the limit of this quotient, then it is same as their derivatives. Now how come the quotients are same as derivatives? Well, if you enlarge and just look at this point, if you enlarge this point, right, then you can see that at this point this curve becomes kind of a straight line, right? So we could draw this curve as kind of like this, a straight line, right? Similarly, g of x is also approaching a straight line at this point. You see that? So these are the straight lines. So if you look closer, very, very close to a, in that case, we have ratio of these functions could be represented by these lines, right? And if I call this slope m1, then I could write this function as y equals to m1 x minus a, right? And if I call this slope as m2, I could write this as y equals to m2 x minus a. So at this approaching point a, what you find really is that the ratio of these two is kind of same as, let me write down here, as equal to ratio of these, which is m1 x minus a divided by m2 x minus a, and that gives you m1 over m2. Now m1 and m2 are ratio of slopes, right? These are slopes. So slopes are derivatives, right? So that is how you get f prime x over g prime x, right? So I hope the concept is absolutely clear. So in general, we can, this is a very simple explanation for all this, but I hope it helps you to understand the very basic concept why when we are talking about limit of quotient of these two functions as x approaches a should be equal to quotient of their derivatives as x approaches a, right? So that is kind of graphical representation. You could actually do it algebraically also. So we could write, actually, let's look into the algebraic expression for limit as x approaches a for f dash x over g dash x. Now, what is this? This is quotient difference, right? So you remember quotient difference? So the numerator could be written as limit x approaches a. Now when it is f of x approaches a, then in that case it is equals to f of x minus f of a, right, divided by x minus a, and the denominator will be limit x approaches a for g of x minus g of a over x minus a, correct? Now that could be written as, now x minus a cancel out, so you could write this as limit f of x minus f of a, I mean as x approaches a, of g of x minus g of a, right? So that is the quotient difference, and that limit can be written as limit of x approaches a of f of x over g of x, right? So that is how you can actually derive this expression algebraically also, right? So in a way, you get kind of an understanding of how to apply Lee-Hospital's rule and get the correct answers, right? So it is normally applied whenever we are looking for indeterminate forms. So indeterminate forms will be 0 over 0, or it could be infinity over infinity, right? It could also be difference of infinity. And we'll have some power rules also, where 0 over 0 form will be considered, infinity over 0 will be considered, 1 to the power of infinity will also be considered. So I'll take up these examples. These are special since to solve them, we may have to take natural log on both the sides. So we'll take them in separate list of videos. And in this list of videos, we'll consider the normal indeterminate forms where Lee-Hospital's rule can be applied. Whenever you apply this rule, you should check that we have 0 over 0 form or infinity over infinity form to begin with. I'm Anil Kumar, and I hope this simple explanation helps you to understand why this rule works, and in coming examples you will understand how to apply Lee-Hospital's rule to find limits. Thank you and all the best.